Welcome back, folks. And so today I thought it would be interesting for you as well to have a look at
for example, when doing research or doing code reviews, they need to collaborate with the user.
Google AI agents.
Confirmation and decisions.
Yeah, just sorry for being in the middle of everything. Now Google has some good news again with Google Cloud I/O, or I would call it Google AI. Still after it is now after 5-6 years ago since we started, maybe 5-6 years ago, Google AI with the TensorFlow and all that was launched. And let's jump into what Google has launched now in 2025 in the summer.
That enables user moderation and control, something we call the human in the loop. Tasks can be performed using tools. Let's talk a bit more about those tools. First, there are the basic tools. Large language models are not good at math or basic time or unit conversions. Image generation. The agent can call another image generation API or generate visualizations from generated data. Browser. The agent can be given control for web browsing and browse websites using a real Chromium-based web browser. This is often done with multiple back and forth between the LLM and the browser service. Code execution. Code is generated by the LLM, and the agent executes it in a sandbox, secured environment. So, in terms of architecture, at a high level, a user will interact with the agent via multiple requests.
Yes, so we are also working with the RAG as a part of with the LLM.
The agent is composed of the serving and orchestration components. This component will
but let's just see the architecture, and then we can
memory and access to data, as well as tools. So, a runtime for AI agents needs to scale to handle many concurrent users using the agent. Of course, be cost effective. Have good latency performance and high reliability. Have a great developer experience for agents developers. Integrate with LLM and tools. Be flexible of running the developer's favorite language and AI agent framework. And have streaming built in so that responses can be streamed as fast as possible to the end user. Cloud Run is a perfect runtime to host your AI agent on top of Google's scalable infrastructure. It scales via automatic, on-demand, and rapid scaling of instances. It is cost-effective via a pay-per-use pricing model. Notably, it doesn't have any flat fee and doesn't require free provisioning capacity. It is fully managed. It has built-in zonal redundancy and is enterprise-ready in terms of security, networking, and compliance. Developers love Cloud. It has top satisfaction and usability scores. Agents developers go from source to URL in one command. Cloud Run services have built-in credentials enabling you to call the Gemini API securely without any API key. You can run any AI agent frameworks in any language, Python, JavaScript, and Cloud Run supports out-of-the-box HTTPS endpoint with streaming, be it HTTP transfer encoding, HTTP2, or websites. So, let's look at how previously described architecture on top of cloud. A Cloud Run service takes care of serving and orchestration. It runs an AI agent framework like LangGraph or Agent Development Kit. It can call the Gemini API or models served via the Vertex AI endpoint, or even your own fine-tuned model running on Cloud Run with GPUs. For memory, Firestore is a great NoSQL database, and memory store can also be used. Retrieval augmented generation can be achieved using Cloud SQL or AlloDB for PostgreSQL with the PG vector plugins. And finally, tools can be hosted themselves on Cloud Run or be called through listening. And now let's hear how to build an AI agent.
Hi, my name is Itze Venema, and I'm an engineer in the Cloud Run team. I'd like to show you a concrete example of building an agent on Cloud Run. Cloud Run supports any agent framework, but I use LangGraph. Let's quickly dive into a few concepts before I show you the app. Let's start with LLMs. You give them an input, maybe a question, a prompt to write something, and they generate a relevant output. They are fantastic tools. But as powerful as they are, LLMs used in isolation have some key limitations. For example, their knowledge is frozen at the time they were trained, and they cannot directly interact with the outside world. So to overcome these limits, the most common approach is to augment the LLM by combining it with other pieces of data and computers. This pattern is called a chain. Think of it like a fixed workflow. As a developer, you explicitly define a sequence of steps. A classic example of this is retrieval augmented generation, or RAG. The big advantage here is reliability. The steps are predetermined, so you know exactly what will happen. The downside, it's inflexible. The chain follows a predefined path and cannot adapt dynamically. Now, a key development that enables a more dynamic approach is tool calling. You can give an LLM access to external tools. When the LLM thinks it needs one of these tools to answer a request, it doesn't run the tool itself, but it generates a structured output saying which tool it wants to use and what information to pass. This tool calling capability leads to this second main paradigm, the agent. Instead of a fixed chain, here we put the LLM in the driver's seat, running it in a loop. The LLM gets the task, calls the tool, feeds the result back to the LLM, and lets it decide the next step. It continues this loop until it determines the task is complete. The big advantage here is flexibility. The agent is not locked into a predefined sequence. However, this flexibility often leads to lower reliability. These basic agents, where the LLM is making all the decisions in a loop, can often go off track. And here's why. Maybe the instructions given to the LLM were ambiguous. Maybe the tools available weren't quite right, or their descriptions were misleading. Perhaps the LLM failed to reason correctly about the steps needed and tries to rely on its internal knowledge instead of using a tool. So, while powerful, this simple looping approach can be unreliable in practice. So this brings us to the core challenge. On one hand, we have chains, reliable, predictable, but rigid. And on the other hand, we have these agents, flexible and dynamic, but unreliable. So the question is, can we have both? Can we build systems that have the reliability of structured workflows and also the flexibility of agents? One way to achieve this is to model your control flow with a graph, like a state machine. In this graph, you have nodes representing specific decision points. Some might execute code, some might call an LLM, some might call a tool. And then you have edges that define how you transition between these nodes, representing the logic and flow of the application. So this is the approach that LangGraph uses. LangGraph is a framework designed specifically to build these kinds of graph-based AI applications. This core idea is to let you explicitly define parts of the control flow using code, giving you the reliability of chains when you need it, while also giving you the flexibility of agents when that's needed. Now let's take a look at my demo to see an example of that in practice. This is my pretend online store from the future, and I am acting as a support agent. Here is a list of my open lists. To resolve them, I can access a repository of standard operating procedures. For example, this is the one that tells me how to investigate failed payments. I also have access to the backend systems. So here's orders, customers, payments, shipments, and finally, invoices. Let's go ahead and resolve one of the support cases. This one looks interesting. This customer really needs their Echo Weave device, but is having payment issues. I've built 3 AI agents to help me do my work more efficiently, so I can focus on providing the best support for my customers. First, my case context agent will help me find all the resources that are related to the case. Gemini uses tools to get all the relevant information, and I will link them to the case. That's great, because that's very repetitive work to do manually. So it links an order for those 2 Echo Weave devices. There is a payment, which failed because of a gateway timeout, and the standard operating procedure that's related to this case. Working through that manual is a lot of work. Let's see if my other agent can help me with that. The SOP agent will read the manual, make a plan for resolving it, and execute the plan. It looks like the payment was successful after a retry. To close this case, let's send a reply to the customer using my third agent. This agent uses all the information in the case to send a personalized message to my customer and saves it as a draft for me to edit before I send it. There it is, and the message looks good to me. Let's reply and close the case. Now that you've seen the demo, let's take a look at the application architecture of mine. I used LangGraph to build my agents, and FastAPI is the web framework to build my web application. Now look, I'm more of a Go developer myself, but Python is clearly my destiny. Finally, I packaged my web app into a container image using a Docker file. And now that I have a container image, I can deploy it to Cloud Run and get an HTTPS endpoint back. Now, I want to show you how I deploy a change to my app. So this is my local editor on my local machine. I'm going to add some text to the homepage and then deploy it so you can see the change. I'll add a paragraph. So I'll save that file, and I go to the terminal and do gcloud run deploy. And I will confirm that this is the directory I want to deploy, and that's the service name. And then I will start building and deploying. So while that's running, I'll take you through a short tour of the web console. So this is my service in Cloud Run. And you can see that I have access to all the metrics, like the request count, request latencies, the number of container instances that I'm running, how much CPU they're using, memory utilization, and also the startup time of my containers. Now let's check back and see if that deploying has been completed. Looks like it's almost done. That's creating a revision and routing traffic. And when that's done, I can click on the link, and you can see Hello Google I. Let's break down that gcloud run deploy. First, it uploads the sources to a GCS bucket. It kicks off a build in Cloud Build, and if you don't have a Docker file, then buildpacks is used to turn your source code into a container image for you. Buildpacks is the open source version of the technology that powered App Engine since 2008. Note that you don't have to run these commands. This is done for you by the gcloud run deploy command. Now once the container image is built, it is pushed to Architect Registry. That's Google's container registry service. Then Cloud Run creates a new revision importing the full image. And finally, 100% of traffic is automatically migrated to the new revision. Cloud Run is designed to make developers more productive, and that's why it's great for running agents. Now, let's look at another way to build agents on Google Cloud with Vertex AI.